Welcome once again. This is the lecture session number 9 of the Artificial Intelligence course, and today we are going to see some of the ML techniques that are actually part of this particular course. So, when we start this, the first thing that I would like to take is the thing that we have left in the last class. We were not able to cover the first order logic. Today, we are going to first see the first order logic. So before I think before starting this, let me just quickly talk about that. What is the assignment? So in the assignment, as you know, that there are two parts into the assignment, and one is the prologue program that you have to write, and one is the prologue program, and another is a agent. So in this agent, as if you have any question, please ask. I think the instruction sheet that was given should be clear to you. It actually says that into the Wampus work problem that we have discussed into the previous session. So there should be a file which actually defines that what is the environment, what is the size, the upgrade, etc. Where is the Wampus? Where is the things? How many settings are means settings are actually provided over here, and there is a specific way to provide that particular setting. This is a text file. In this text file, your program should read, and in between, it should have this kind of understanding, and then after that it try to solve this problem so that you can get a goal. So I have actually requested you to write this program into Python, and this program is Prolog. Prolog is also, you can very easily find out 1 hour or 60-minute things. Look, you need not to be very expert into the Prolog. Only thing is this, that you should be able to write some of the predicate, and after that you should be able to do some kind of inferences. And however, inferences you need not to do. The program would by itself would do the inferences and give you the values. So this is the thing that I wanted to tell to you. You need not to worry about much about the things. Okay, so let me start. So now I'm going to talk about the first order logic. So first order logic actually we have into the previous things said na, that how you represent the facts. So if you represent the fact in the right way, then you can find derive good kind of things from out of that. So first order logic is also called as a predicate logic, and here important thing is that it gives you more flexibility and it is more structured. So that's why you can represent many things in a more easy and efficient manner. So there are constants, there are variables, there are predicates and functions. So there are four things that are actually here. What is constant? For example, if I say that apple, okay, apple, I say mango, I say car, I say Ram, I say Mohan. So I say anything. If I say anything, these are the actually constants. So when we have a constant, then we can put variable also. So for example, I have a variable. For example, I have a variable x that can take the values. So let's assume that it can take the value car, bus, train, road. So you can see that this is what the variable is. Variable can take the any value of the constants. And now the important thing is predicate that actually tells if I say that such as student. Okay, I say that student is a predicate. So if inside this I can tell anything, for example, Ram. So Ram is a student. Okay, King, King Mohan. So Mohan is king. Okay, so the predicate actually defines something. If you inside this you say something, so that particular thing has this particular property. Then comes the functions. Functions are actually going to give you some value. For example, A's. Okay, so if I say that A's of Ram, okay, so it is going to give you a value. For example, 30. So if I say teacher KT, so KT is a teacher. If I say that A is KT, so A is KT is a function that actually try to find out that what is the age of him. So by this you can get the number. So it is more structured way of writing something. So for example, if let's assume that you want to write that everyone have a mother. Okay, So it also need some kind of other variables that actually can specify something more. So there are few things. For example, for every x, this is a property. If I say something like this, this property is actually, our predicate is actually true for all the values. There exists x, so there is one, at least one such thing which has this particular property. If I say that there exists as such that px is mean that there exists at least one. So for example, if I wanted to say that everyone has mother, okay, so I can say that for every x, please see, for every x there exists y, okay, such as mother xy. Am I right? So let's assume that predicate mother xy means what? That x mother is y. Okay. So this is how we can say. So if we write the things into this particular way, it is a better way to represent. Okay. Uh, somebody's mic is on. Please mute yourself. Can you please mute yourself? Everybody, please mute yourself. Yeah. So if you want to say, please unmute and please say. Okay. So this is how I can go. Okay. For example, if I wanted to say that A is of, for example, if I say that A is of mother is greater than child. If I want to say this thing, how can I say this? So in the same statement, I can say that for every x, there exists y, that mother of mother xy. So y is the mother of x. It means and age. Then I have to write something like this, that I have to define a function that can tell that what is greater. So I say that and is actually not written. So directly we write. So we write greater age of y comma age of x. Okay. Here I am going to use the functions also. Using this particular functions, it is going to find out that what is the value of y, what value of x, and by this you can say this. So this statement is something like that. That age of mother is actually greater than the child. Okay. So let's assume here we have some example also. So let's assume that we want to write this. Not every customer had purchased milk and bread. Let's assume that you want to write this. Not every uh, customer has purchased milk and bread. How can we write this? Okay, so actually we want to say that there exists a customer who have purchased uh, not every customer. So have purchased the milk. So I can say that customer has either not purchased for every x. Yeah, I can say that there exists x. So there is someone, please mute yourself. There exists x. There exists x such that customer customer is x, because not every customer has purchased the milk, so he must be a customer x is a customer, and and purchase purchased, okay, milk x means x has purchased milk, or purchased bread x. Okay, since I want to say that not of this, so not purchase milk and eggs is false, or this thing is false, one of them is false. Make sense? Any questions on that? Okay. Okay. Yes, say again.
But sir,
Only
can you
one.
hear me? How will
Yes,
we
yes.
decide which variable has to come first?
Which variable have to come? So here there is only one variable.
There is purchase milk, comma x. or purchase X comma milk. What is the difference?
Okay. So as I told you that all these things are actually dependent upon our own way of writing this predicate. So the definition of predicate tells that if I put x, y or y, x, so what does it mean? This is on you. You are going to define. You can tell that the first thing which I write is actually going to represent this thing. This is your thing. You can define by yourself.
Okay. Fine.
Okay. So now there is something that only one customer has purchased guitar. Let's assume that I wanted to say something like this, that only person have one customer have purchased the guitar. How can you write it like this? So the idea is this, that there exists x, there exists x, such as that he is customer, x is a customer, and he has shop guitar, x has shop the guitar, customer x. Okay, and he has shopped the guitar. So there exists someone who has actually purchased the guitar. Make sense? And with this, there is one more condition, that for every y, whoever is there, if he is also a customer y, and and I say that x is not equal to y, means he is a different person, then uh, then then it implies that he has shop guitar, y has sharp for guitar is not like that. Does it make sense? That what I'm telling, that there is just x, that he is a customer and he has shopped the guitar. It means that there is someone who has shopped the guitar. But for everybody else, if he the second person y is also customer and y is not equal to x, so he has not shopped the guitar. Okay, so some of the things are here. So just try to by yourself to write something. So for example, only one customer have purchased guitar and pen. How can you write like this? Highest purchase in forenoon is more than afternoon. So if you define, you want to write this statement, you have to define that what is forenoon using predicates, and then you define appropriate predicate and go ahead with that. Okay. If you write a first order logic, then you can also do some kind of inferences on top of that to find out the new discoveries, new things. Okay. So what do I mean by this? So you know that why we were writing into the logic. We were writing using the logic so that at the later point of time it is required. If it is required, we can derive some new kind of knowledge out of that. So So there are few rules. One rules is this, that universal elimination. If there is something for every x is there, then you can, for example, if it is like that, for every x feels x king. Okay, means x feels like king. So if it is the statement, so here you can put anybody. Okay, here you can put anybody. For example, I can write feels Raju king. So Raju feels like king. Here what I am doing a substitution where x is substituted by Raju. Okay. In the similar way, we can also do the existential elimination, where I say that there exists X that he feels something like this. So here also you can put that there is some man who is feeling like that. Similarly, we can do the existential introduction also. When, for example, when feels Raju king, then you can say that there exists someone who feels like king. Okay, because you know that Raju is there. If this is the, for example, if this is the information you have, then you can write that there is just some X that does all these things. So I'm talking into the abstract term. Sometimes it may be sound you something uh, very loose, but when you would go and apply in a particular domain, then the things would be more clear and they would be having more better representation in your thing. So here is an example, and that actually I wanted to come bring in front of you so that you can understand this particular concept better. So let's assume that this is the information given to you. Okay. And what is the information? Let's assume that these three statements are given to you. So what are these three statements? It is crime for Magad, means the person who is there into this particular place, to sell formula to a hostile country. For example, somebody in India is going to sell any nuclear formula to Pakistan, for example, something like that. So country Hind, there is another country, is an enemy country of Magad. For example, here I think in this example, Magad and Hind, there are two countries, and here Magad is an enemy. Magad, Hind is a enemy country of Magad, and he have purchased some formula from Dara, and Dara is from Magad. So let's assume that this is what it is. So if it is the setting that if somebody sells formula to a hostile country and he is from Magad, then he is a criminal. Okay. So let's assume that these are the setting. So how can I represent this as a knowledge? So I can write that for every xyz, okay, if Magad X, somebody is from Magad X, okay, Magad X, and and Y formula, and Y is a formula. I'm writing this statement. It is crime to for Magad to sell formula to hostile country. And similarly, I can say that hostile Z is a hostile country. Okay, and I say that sell. Somebody is selling. X is selling Y to Z. Let me write like this. X is selling Y, which is a formula to Z. Let's assume that this says this. Then it is crime. Criminal X. I say that X is a criminal. Am I right? Okay. So this is the first statement. The first statement is this. For every X, Y, Z, where what is X? X is the somebody from Magad. Y is a formula. Z is a hostile country, and if there is a selling happening, sell happens between X, Y, Z. X sells Y to Z, then criminal X. X is a criminal. So this is the first statement. Second statement: country Hind, an enemy of Magad, have purchased some formula from Dhara. So enemy Bhind and in country Bhind. So I say that uh, ki hostile Bhind. I can write like this. This this gives me that Bhind is a hostile, and it also I think there is one more thing. Have purchased some formula from Dhara. So there is someone that and formula. There is some formula Y, and there is some selling of Dara with Y to Bhind. This is also information. This is coming from the this is coming from this particular thing. Am I right? It is telling that this Bhind is a hostile country and there is a formula. So when I write this, essentially what I mean that these things are actually tautologies. I mean these things are true. So if they are true, so uh, and one more information. I think one more. The third line is this. Dara is from Magad. So I say that Magadhra. So this is also true. So all these information are given to me. So if this is given to me, so I can put this information over here. Magad Dara means I can apply this Magad Dara. By this I can find out that this becomes X for every Dara Dara. And what is Y? Y is a formula. I know that Y is a formula. What is Z? Hostile Bhind and hostile Z. It means that if I write here Bhind, I can say that Magad Dara and formula Y, and hostile Bhind and cell Dara Y Bhind implies what? Criminal who? Criminal who? Who is this X? Dara. Now I wanted to understand whether this statement is right or not. So this is Magad Dara is given over here, so it is true. Formula Y is a formula is true. Hostile Bhind is also true. And this is also true. So when everything is true, true implies what? This thing. It means that Dara is a criminal. So this is a kind of deduction that I actually wanted to tell you, that if you entail all the knowledge, then by this you can come up with some kind of new knowledge that can come, because it was not provided over here directly that Dara is criminal, but you did something. By this you are able to understand that Dara is criminal. Any questions on that? Correct. So so after this part, I would like to go to the things which actually I brought for this particular class is the machine learning. So ML part I'm going to start today. So before starting, I wanted to tell you that there is a website called http://ktiwari.in/ml. In the same way, you know that ktiwari.in/AI is there. So you can go and search here ktiwari.in/ml. So this is my machine learning course that I offered long back, I think 1 year back. So here in this particular place, if you go to see the resources, okay, here into the resources, you can see a lot of lectures. Okay, so these are the, by chance at that time, it was a online session, so I was got a chance to upload all these videos. So many videos are there, many PDFs are there. So whatever I'm going to tell you, if you want to get anything into the more details, you can go and see from here. So let me start talking about the machine learning. So what is machine learning? So sometime what happens now, if you have some problem for which you don't precisely know that how to solve them, are very difficult to specify the solution procedure. For example, when you see me, you are able to identify that this is your faculty. So how you do that? So how can you tell me that how your brain is working and going to give you this information that this is your professor, this is your friend, this is your boss. So how the processing is done? You are not able, you may not be able to specify this. You are able to do that, but you are not able to specify this. So with these kind of solutions where you are not able to specify, and sometime it becomes very difficult for you, you go for the machine learning. In the machine learning setting, what happens that the very important and distinguishing part of the machine learning is this, that things happen automatically. Okay, so into the computer science we actually do many things such as algorithm development and system development, but artificial intelligence is one part which actually concentrate that how can we bring intelligence to the computers. Okay, what do I mean by intelligence? I think we have talked about this earlier also. So by intelligence, we means that there are actually three categories of task. One category of task is this, for example, when I'm telling something, you are listening it and you are able to understand this, interpret it. This is intelligence. So this is mundane task that you are actually going to do. Then there are some formal tasks. For example, when in this particular class you are sitting and I'm talking to you, you are understanding. So you by yourself think that you are doing some kind of intelligent task because you are sitting into the class. The third kind of class are intelligent tasks are the specialized tasks. For example, I can tell that I am specialized into the teaching. Some doctor is specialized into a special kind of surgery, and some architect is specialized to build some kind of architecture. So when he is doing that particular task, he may be thinking that he is performing those intelligent kind of tasks. So these three category of tasks, if we want to be done by the computers, so how can they automatically get that kind of capability to automatically do those kind of things? So this particular thing actually comes into the purview of the artificial intelligence. Into artificial intelligence, to build these kind of system, various things are maybe required. So there is one area which actually talks about that when we wanted to do something, there should be a proper mathematical basis, and we should not teach to the computer that how to do that. Maybe computer should be able to figure out by doing this thing multiple number of time and learning. So that particular thing, uh, this is one way. Another way could be that you build a table and solve the particular problem, you do the search, you do other things. So if you divide those things into two parts, so the other things where the mathematical sound, mathematical background is there, and where um, where the sound mathematical background is there, and automatic learning is going to happen, is called the area uh, where we say that it is machine learning. In the machine learning, if you want to do something, so there are various way, as I was telling that there are strong mathematical way. Along for this, if you want to model those things, sometimes you model that how the brain is working. If in the same way the brain is working, you you decide that you are going to make the circuit. So it is called a neural network. It is resemblance with the neural architecture, human neural architecture. Then this is called the deep learning based architecture. So this comes as a deep learning. So multiple ways you can do the machine learning. Out of them, if you select that I'm going to proceed into the neural network way, then it is called the nowadays deep learning. Multiple things has actually emerged over there. So this is the broad way that things are there. Into the machine learning, if you want to do something, there are two different kind of tasks actually. Sometimes you want to do uh, something. So what you can do with the machine learning? So two different kind of tasks. In the first task, actually that is predictive. So what happens that in the predictive kind of task, you are actually more concerned that what is new for me. Okay, so what happens that let's assume that this. One minute. Let's assume that some data you have some data. Okay, so let's assume that this some data you have, and then if the new data is coming to you, so you can using the knowledge that you have here based on some understanding of this particular data, you can tell something about this particular new data. Yes or no? If you have some data, if you apply some kind of techniques to understand that what is there, then you can apply that understanding on the new data and tell something about this. If you are going to do that, it is called the predictive kind of machine learning, where you are actually predicting outside things. So here you either want to do the classification, means you want to attach a particular kind of label to this particular thing, or you want to do the regression, means find out some value for this thing, or time series analysis. If the data is into time series, you want to do the time series analysis, and prediction means if it is a series, then you want to tell that what is going to next. So all these things you want to do when you are going to concentrate on the new things. And the second part is actually descriptive, where actually when you are not going to talk about the outer things, you are actually not going to talk about the outer thing, you are just wanted to describe that what is inside this. And the purpose is to explore this particular data more. So one thing could be clustering, that actually tells that how many logically coherent part are of this particular data are there. So you want to do the clustering. Sometimes you want to do the summarization. If this is a lot of data, so how can you represent using less number of words or something? Association rule mining, sequence discovery. These are the few of the tasks that actually you want to do on that. So there are many type of learning. People talk about this supervised learning, when the right examples are provided to you, right answers are provided to you for the data, and then for the new item you have to tell the right answer. Unsupervised, and this the second part that I told to you, descriptive one is actually unsupervised, where you are not told anything about the data. You have to come up with the description of the data. This is the unsupervised one. In the unsupervised one, right answers are not given. System by itself try to understand that what to be done. Semi-supervised, you can think that in between, that for few example the answer is given, for others answer is not given. Active learning is another kind of setting where what happens now, for example, when I'm teaching to you, maybe I'm teaching those things also which actually you already know. So if you are allowed to ask the question from me, so you would only ask the question where you have a confusion. So it would be effective for you. You in the less time you'd be able to learn that. So this is the active learning, where the person is allowed where the to ask the question, where the model is allowed to ask the question. So he can ask the question where he have a confusion, and then those for those examples he actually train the system, and that's why the system becomes very easily very easily you can train. So the time, with less time you can train it, maybe more effective way also. Then comes the lazy learning, and lazy learning means what actually, when the data is given to you, lazy learning system does not learn anything until somebody asks anything from him. Okay, for example, if somebody is giving you so many things, so many, I keep teaching you. So if I don't take exam, so you may not. Sometime you some students are good that whenever I'm teaching something, somebody is actually going to take them notes and consolidating the knowledge, and so that they can apply somewhere. But sometime what happens that whatever is there, let me put into my space, and whenever somebody is actually going to ask me any question related to that, then at that time I would do the things. Then comes the reinforcement learning that actually talks about that. That I'm not going to, for example, I'm not going to tell the system. System should automatically do something to figure out that what to be done. So this is actually applied into many complex kind of environment. For example, when there is a robot, it want to explore some area. So this information is not given to him, but as he sees something nearby, he keep constructing the environment, and this could be a part into the reinforcement learning system. Uh, Actually, most of the time into the game playing kind of scenario, it is more effective. Then comes the transfer learning, where we actually learn something to do something else. For example, if you want to learn a bike, so first you would go and learn that how to ride this bicycle. So if you are expert in riding the bicycle, then you go to the bike and apply this thing, that how to balance the cycle to the bike, and then you can run that particular bike. Deep learning, as I mentioned, that is a special kind of new area which actually developed into the machine learning, that actually talks that I'm going to use only the neural networks. There are many areas where the machine learning can be applied, and generally there is no such area where ML is not applied. So all the areas you just name it, everywhere the machine can be applied. This is the general flow of the machine learning, and this you must please see with very careful eyes. Okay, so what is this? So actually what happens that if you want to build a machine ML based system, so your objective would be to find out a function that if I give you some data, it can tell that what is the label or some output, because input output is associated with the data. So it can tell that what is the output for that. And this output is actually how can this output be obtained? We think that there is some function that gives me this particular output, and we assume that there is some function, there is some correct function. Let me say C function, concept function, or God function that provided the value of X, give me the value of Y. But since we don't know that what that particular function is, because we don't know, so nobody has told me. I am only observing the data. So whatever function I come up with, I say that it is a H function, and this is a special name that is called the hypothesis. Okay, hypothesis function. This is the function that actually I am going to propose. So this function is also going to give me the value of y. So I can tell that y estimate is given by my hypothesis. What I want that this y and y hypothesis, y and y hat should be the same. Means the difference between y and y hat should be very less. Okay, should be equal to nearly equal to 0. This is my objective is. But what happens that actually let's assume that there is some data. Let's assume that there is some data. On this I create the y. Okay, how I created? Let's assume that the God has created. So using some concept function, he has created this particular y. But I'm going to tell you a very important thing. But what happens that let's assume that this is what the real scenario is, that you have a data, and for that particular data you have value of y. But how can you obtain these values? How can you obtain these values? You have to measure. You are measuring something, and this I am going to tell the observation. So if you do the observation, so there would be some error. Okay, you cannot observe everything perfectly. There would be some noise, because the noise is a fundamental property of all the things. So it would definitely be there. So you are going to get something different. However, the y value that you are observing, most of the time you are not going to give error into this. So instead of actual database, instead of actual database, you are actually going to get a different version of this particular database. However, this error and noise would be very less. We assume like that. So this is going to serve for us as a training data, and from this particular training data, um, your objective would be to give me a hypothesis function. That function provides you what? Y hat, and the difference between, as I told you, that y and y hat should be actually lesser. So again, the how to come up with this particular hypothesis function? Again, you apply a kind of bias that looks like that I am going to create. For example, let's assume that this particular data is it contained x1, x2, x3. I can write something that x1 e to the power x2 plus say 100 x3. I come up with some kind of formula. Okay, and I say that there is a parameter A, there is a parameter B, there is a parameter C plus D. Let's assume that these are the four parameter I write over here. So by changing these parameter, what is the value A, B, C, and D? This particular formula can take different ways. For example, 3x e to the power 2x2 plus 5 plus 2x3 something we here. What is the value of ABC? You can by yourself figure out. So by changing this particular parameter, I can come up with a different kind of functions, and these functions I say that they are hypotheses. So you can think that what are the all possible functions. Out of these all possible functions, there would be one function which has the highest accuracy. Yes or no? Out of all these functions, there would be one function which has the highest accuracy, which could have the highest accuracy. Yes or no?
Yes.
There will be one function which has the highest accuracy. Then you can return that particular function, and therefore the task of machine learning is what? That on this particular data, that is actually this data, on this particular data, it is going to evaluate all these function and tell that what is the accuracy of this particular function. And if there is a systematic way, so it can efficiently find out that particular hypothesis which has the highest accuracy. And this is the task of machine learning. Okay. Please note that it's not easy because the data actually in on the data on which you are actually training, it is not the same data which actually should be here, because actual values I don't know. If actual values I don't know, because of this observation there was an error, and with the error and noise the data that I have, I'm telling that this is the data I have for the training. Okay, so this is the biggest issue. And on this transform data, I actually want the highest accuracy. This is the challenging part of all these exercises. Okay. So I wanted to ask a question that let's assume that I have a database. Okay. And I wanted to find out that what is the probability of viewing getting that particular data. It looks weird. Then probability of looking and getting a data, what does it mean? So you know that yeah, let's assume that things are actually coming into the from the random experiment. So if you let's assume that I say that probability, let's assume that you are flipping a coin. What is the probability of head? Let's assume the probability of head is the 0. So what is the probability of tail? Is equal to 1. Is it possible? Yes or no? Probability of head is 0, probability tail is 1. Is it possible? Yes or no?
Sir, only if the coin is like one side is clear.
Okay, so it is possible, na? It is possible. Okay. So, but you want to tell that when the coin has special kind of setting, then only it is possible. So let's assume that this is a setting. If I ask you that I have flipped this coin, I got this observation. If I say that I flipped this particular coin and got this observation, what was the observation? Let me just give you. I say that tail, tail, head, tail, tail, tail. Is it possible? No, it is not possible, because how come you get a head if the probability was 0? So this is actually important, that whenever you are going to tell me an observation, I can tell something about this, that whether it is right or not. For example, let's assume that I say that head, head, tail, tail, head, head. What is the probability of head, head, tail, tail, head, head, when the probability of head is equal to 0.4? Okay, it is given here. Probability of head is equal to 0.4. What's the probability that you see this particular thing? So if you want to see this thing, so initially there should be head. So head is the probability 0.4. Then there should be head 0.4. Then there should be tail 0.6. The tail into 0.6 into then head 0.4, 0.4. So by this you can find out that what is the probability of this particular expression. Okay, and then you can come, for example, this is a value. It gives you that what the probability of seeing this particular data. However, as you know that in the data, if you change the order, it is not going to matter. So in how many ways you can arrange this thing, if you multiply this, then actual probability you can actually come up with this. So what is on what thing it is going to be dependent. For example, if when I come up that probability of seeing this data is something, some value. So on what thing it is going to dependent? It is going to dependent upon the parameter. What is the parameter? That what is the probability of head? If I change the probability of head, then the probability of seeing this particular data actually changes. So let me give you an example. Let's assume that in the very simple setting, let's assume that I have an input variable x and an output variable y. The value of input variable is 10, 11, 12, 13, 14, 15, 16, 17, 18. And what is the value of y? Let's assume value of y is 0, 0, 0, 1, 0, 1, 0, 1, 1, something, some y is there. Okay. So this is the right thing. Okay. This is the right answer that is given to me. But if you apply any kind of hypothesis function, how many hypothesis function are possible? Many hypothesis function are possible based on my setting. Okay, so let's assume that I have set up with some hypothesis function and my output is this. My output is this. Output is this. Okay, what is this? What I'm telling? My output is this. This is my output. So can you tell me that what is this hypothesis function? Can you tell me that what function it is? 0, 0, 0, 1, 1, 1. What function it is? You can say that h1 is equal to what is this? H1 is equal to that if x is greater than 12 or not. Am I right?
True, false.
Yeah. Similarly, what is h2? 1, 0, 1, 0. This is this kind of function. So how many? What this function is? When it is 10, it is 1. When it is 12, it is 1. So is it even
Not.
or not? Okay. This is what the function is. Okay. So my question is that how many such functions I can create? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 different inputs are here. So I can put 0, 1, whatever I can put here. I get a new hypothesis function. Okay. So there are 9 places I can put 0 and 1. In how different way I can put 2 to the power 9 way. So 2 to the power 9 different hypothesis function I can write. One of them is definitely going to be this also. Yes or no? So a machine learning task would be to find out that particular setting which actually has this particular value, then there would be no error. Okay. Yes or no? Yes. Machine. Everybody. Yes or no?
Yes, sir. Yes.
Yeah. Okay. So we are going to see some Bayesian understanding of this. For example, into the Bayesian setting now, what we can say this. In the Bayesian setting, what we can say that some database is given to me. There are various hypotheses. Okay. Setting is this that a few minutes back we had talked about that there are various hypotheses. Okay, H1, H2, H3. I want to find out that what is the goodness of this, what is the goodness, what is their goodness, and the hypothesis which is the most good I'm going to return this as my hypothesis, final hypothesis, output hypothesis. So in the hypothesis set, I wanted to find out how good they are. Okay, given what? Given the data. So I wanted to find out what is the probability of this particular hypothesis given the data, and the thing which have the highest probability is going to be the best hypothesis for me. Yes or no? What is the probability of hypothesis? Few minutes back we have talked about this. But probability of data hypothesis we want to understand with respect to given data. What is the probability of this particular hypothesis with respect to given data? I want to find out this value and the hypothesis for which this particular thing is larger. I'm going to tell that this is the best hypothesis. Yes or no? Yes. Yes. So how to find out this particular value? So Bayes rule actually comes into our rescue. It tells that probability of hypothesis given x is equal to probability of d given data given hypothesis and probability of hypothesis and probability of data. We can write like something like this. So we can further investigate this thing. So as I told you that I wanted to give you that particular hypothesis which have this particular this that hypothesis maximizes this. So argmax is a function that gives that which particular hypothesis has the highest value of this particular quantity. So such particular such hypothesis would be called the maximum posteriori hypothesis. Okay, maximum a posteriori algorithm is going to be that algorithm, that hypothesis which have the highest value of this particular quantity. Yes or no? So as we discussed that this particular quantity is probability of data given as one probability of h in divided by probability of data. Since probability of data does not have any hypothesis component into this, so we can simply neglect that particular part and we can tell that map hypothesis is probability of data given h and probability of h. So what does it mean? It means actually what does it mean? It actually means that look, probability of probability of h given d, we are interested in that. Okay, but probability of h given data we directly cannot find out. I told you that take it probability of data given h. Probability of data given h is something very interesting, that because it has a parameter na. So using this parameter I can find out that what is the probability that I can see this particular data. In the previous example what I was seeing that when the probability of head was given, then I can tell that what is the probability of a particular observation. So if the probability of head is given to me, or the probability of something data is given to me, then I can find out this probability of this very easily. And let's assume that somebody gives me that probability of hypothesis. What is this? That various probabilities are there. Let's assume that priorly I am very much favoring this particular hypothesis. There are various hypotheses, but I'm telling that looks like that I consider this with the 0.1 probability, consider with the 0.2 probability, consider this with 0.3, 0.1, 0.1, 0.2, something like this. So it means that there is some hypothesis which by myself actually favor most. So this is coming from this particular component, that what is the probability of hypothesis. Then using this thing you find out that if this is the data, what is the probability that I'm going to observe this thing, what is the probability. Then the multiplication of these two things you are going to tell me. So when you multiply this thing over here, it may be possible that the multiplication of those terms could be larger for this quantity. Then this becomes the high hypothesis that is going to be reverted to me. And this hypothesis would be called what? Map hypothesis. There is a name that I've called that this is the map hypothesis. If you understand this setting, so you can tell that why I am going to tell that it is a kind of bad thing that I'm telling that I'm going to consider these things with this is probability. If I don't say this, that I'm not interested in this kind of understanding, it may be also possible because we don't have that much information that I can come up with this kind of probability distribution. So I say that I'm assuming all the hypotheses which are in my hypothesis to be equally good. If I say that in my hypothesis space, all the probability hypotheses which are there, I say that they are equally good, then we can say that this particular quantity I can say that equal for all. So I can also neglect this particular part. Then this particular formula further simplifies that, only says that what is the probability of D given H. So in this kind of setting, in this kind of setting, if I say that this particular quantity is equal for all the hypotheses, then I need not to consider this thing, because ultimately I'm going to not interested in the value, I'm interested into that particular hypothesis. Then I can tell that I can reply hypothesis using this particular formulation. And this particular formulation is called the maximum likelihood ML hypothesis. Okay, this understanding is called what? ML hypothesis. So now I have a question for you. Please answer this question. बहुत simple question है. What is ML? What is ML hypothesis? Maximum likelihood hypothesis, and map hypothesis. What is ML and map hypothesis? So you would tell, sir, in my hypothesis space, various hypotheses are there. My machine learning task is to give me one hypothesis. So whether I consider all these hypotheses which are here to be equally good, then it is a whatever hypothesis I am going to give you, it is called the ML hypothesis. If I say no, I am going to tell this, I am going to have more weightage on this, then it is a map hypothesis. This is the difference between ML and map hypothesis. So let me go and see an example. So here, let's assume that in the same example that I had, in the same example that we had, we had this example over here. So two hypotheses we had. So if I wanted to find out that how good this particular hypothesis is, H1, so I would match na term by term. So here it was 0, but it is giving 1. It was 0, it is giving 1. So it do two places it is going to have the wrong. Otherwise, all other places it is going to be correct. Am I right? Similarly, H2 hypothesis, if you compare here, it was 0, it becomes 1, 0 becomes 1, 0 becomes 1, 1 becomes 0, 0 becomes 1, 1 becomes 0. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 places there is a problem into H2. One place there is a problem into H1. So let's assume that I have a setting. So can you give me that which algorithm is better? If I ask you that, can you give me that which hypothesis is better out of these two only? Okay, two hypotheses I have. So as I'm telling that, how many hypotheses I have? H1 and H2. Few minutes back I was talking about that. Let's assume that there are many, but let's assume only two hypotheses are there. So what is the goodness of this particular thing? 7 by 9. What is the goodness of the second one? It is 2 by 9. Am I right? 1, 2, 3. I think 3 by 9. Na? 3 by 9. 1, 2, 3, 4, 5, 6. 6 places it is wrong. Goodness is 7 by 9 and 3 by 9. So let's assume it is given that somebody told me that I have a bias that H1 is 2 by 50 and H2 is 6 by 50. I have another bias on this particular thing. Okay. So correctness probability, you know that 7 by 9 and 3 by 9 we have just computed over here. So posterior probability, what is posterior probability? It is 2 by 50, 2 by 50 multiplied by how much? 7 by 9, okay? 7 by 9. It is 14 upon 50 into 9. And the second one becomes 6 by 50 and then you multiply this with the 3 by 9. It is 18 by 50 into 9. So which is the highest? Which is the largest value? This is the largest value. So if I ask that give me the map hypothesis, so map hypothesis multiplies the probability and both the things. That's why it replies. It gives you the H2. In the same equation, if I ask give me the ML hypothesis says that don't multiply this thing. Only consider this thing. So who is the in the ML? Who is the winner? 7 by 9 is larger than the 3 by 5. In the ML hypothesis is H1. Okay, so this is how you find out that what is ML and map hypothesis, and you understand this particular thing. So how to proceed into this particular scenario? So how to proceed? Can you give me the idea? So for example, if multiple hypotheses are there, how you proceed? So one way is you do the brute force method, or you do some other technical way, so that I'm not going to that discussion that because they can be very large. 2 to the power 9 may be a big number. So if we have 100 examples are there, it becomes 2 to the power 100. Finding out 2 to the power 100 becomes practically impossible. So how to find out a good hypothesis in that particular scenario? So we have to do something on that. Now let me talk something different, and this time I wanted to talk about this, that a few minutes back what I was talking about, that that given the data, a few minutes back I was talking about that given the data, you wanted to your machine learning task to give me the hypothesis that is going to work well on my data. Yes or no? But why I want to do this hypothesis? Ultimately, I am going to use this hypothesis to find out that what is the value of y estimate. So why don't I directly come and talk about this, that on this particular given this particular data for a new particular data item, what is the y hat? If I directly talk about this, and say that what is the most probable classification for the new instance. So now I am going to talk in terms of the Bayesian setting. Okay. So there is a classifier called the Bayes optimal classifier that can help us to find out this particular value, and actually gives you the idea that maybe you could do better than the map hypothesis. Okay, a few minutes back we had talked about the map hypothesis. So okay. So let's assume that the posterior probabilities of the three hypotheses. Let's assume that I have three hypotheses is 0.4, 0.3, and 0.3. Okay, let me give you the idea. Okay, so let's assume that I have three hypotheses. Okay, I have how many hypotheses I have? I have three hypotheses. Okay, H1, H2, H3, and they are in my hypothesis space. And let's assume that when I computed the posterior probability, then it comes out to be 0.4, 0.3, and 0.3. Okay. So which you are going to select? You are going to select this because it has a higher value. Let's assume that you apply this and you got the positive for this. Okay. It is the classification given is positive. So what is the classification of new item? If there was a new item, on this particular item, what you have to do, you have to apply this for this only because it has the highest probability and it gives you positive. So you say that this particular item is positive. Am I right or not? So if, however, if you change the mindset and try to figure out with respect to every hypothesis, what happens that this, and let's also assume that these two are going to give in negative, but I have just completely neglected them. But if I consider everything, then I would ask, from here I get 0.4 probability of positive. From here I get 0.3 probability of negative, 0.3 probability of negative, so 0.6 probability of negative. Can you see this? If I consider all the hypotheses, then the probability that the item is going to be negative is 0.6. So should I take 0. Positive or negative? So if I decide to go into the negative one, it is called the Bayes optimal classifier. This is the Bayes optimal classifier where for every classes, I'm going to find out that what is the probability that it is going to give me that particular label with respect to how good this particular hypothesis is. So I multiply these two things, I get this idea. So Bayes optimal classifier is this. As I told you a few minutes back, the same calculations, 0.4 and 0.6 that we had did a few minutes back. So this is the best hypothesis. This is the best classifier that is possible. So no other classifier can be better than this classifier. So this is the best classifier. However, there is a problem, and the problem by yourself can think that few minutes back I was telling that if the number of examples are 9, then 2 to the power 9 hypotheses were there. So generally 9 examples are not there. Na? You generally there are 999 algorithms examples are there. Then how many hypotheses are there? These many number of hypotheses are there. This list becomes very large. If this list becomes very large, how can I come up with these probabilities? Become totally completely impossible for us to go ahead. So this is the biggest problem with this Bayes optimal classifier. That's why we cannot even apply this into the practical scenarios. Then comes another solution that is called the naive Bayes classifier. And naive Bayes classifier actually puts a kind of assumption that attribute values are conditionally independent given the target value. Means if we specify the target values, then these values are actually independent. What does it mean by this? So what actually it means that if this is the quantity actually we wanted to find out, now the same quantity which actually we wanted to find out. This is the quantity that we wanted to find out. So so we have actually talked about that this is actually not important. We have actually removed this particular part and we told that what is the probability of this particular thing and goodness of the algorithm we want to find out. So actually it says that if we apply that things are independent, so how can we find out this probability? I can say that since independence is there, so I can say that probability of A1 given Vj into probability of A2 given Vj So it becomes very easy to multiply all these individual terms, probability of individual terms. Okay, so finding out this particular probability is actually but very difficult. Okay, and this naive, because of the assumptions of the naive base, this particular thing becomes easy. And now you can ask this question, sir, is whether this assumption is correct or not. That is mostly not correct. Okay, but this actually simplifies our problem a lot of finding out the joint probability, and most of the practical scenarios is actually works. This is the only thing, and that's why it is a good way of finding out the classification. Okay. So as I told you that this particular quantity becomes a multiplication, and this particular is only single value dependent upon the output value. So it becomes easy for you to go ahead with the answer. So let me see an example. Let's assume that this is the example given to you, a database example where how many examples? 14 data examples are given to you. In every row, outlook, temperature, humidity, and wind values actually provided, and at the end there is some yes or no that actually wanted to tell that today do you want to like to play or not some game. So for example, on the some day 10, it was rainy, mild, normal, and weak, and you wanted to play. So, okay. So let's assume that this data is given to you, and I wanted to find out the classification for this rainy, hot, high, and strong. Rainy, high, hot, and strong. So this is not into the table. So you have to do something to find out what is the value of play, yes or no. You have to do something to find out this thing. How to do that? So let's say let me apply the naive based classification method. So what it was told that when you actually segregate with respect to the classes, then they are independent. It was our assumption. So we are going to divide the data into two parts. So when we divide like this, what is the probability of no? 1, 2, 3, 4, 5, 5 upon 9. What is the probability of S? It is 9 by 14. And then we can go and, for example, for this particular attribute, outlook attribute, I wanted to find out that for the S one, what is the probability that it is sunny? So you can say that sunny is 1, 2, two places, na? So it is 2 by 9 because here 9 examples are there. Only 5 examples are here also. Only 2 by 9. What is the probability that when it is sunny, it is no? 3 by 5. Similarly, what is the overcast? Here is see 1, 2, 3, 4. It is 4 by 9. For the no, you come here, overcast is not there, 0 by 5. For rainy, you come here, see rainy 1, 2, 3. So it is 3 by 9. And similarly, no is 2 by 5. Okay. So with respect to the outlook, temperature, humidity, and wind, you find out the similar values into the table, and then you can combine this value to find out that what is the probability of S and what is the probability of no. So what is the probability of S? This was the formula that this data, let me call it x given S, and what is the probability of S? X given S is what? Rainy, hot, high, and strong, everything was there. So rainy given S, hot given S, high given S, and strong given S. These probabilities we can find out from the previous table. For example, rainy given S. So rainy given S is equal to 3 by 9. Okay. So it is 3 by 9. Similarly, hot given S. So where is the hot? Hot given S is 2 by 9. So it is 2 by 9. Similarly, you can find out the table for values from there. Multiply, you get some value. Similarly, you compute for no also. You see that the value or no is actually larger than the value for S. Therefore, the classification is going to be no. So this is an interesting fact. So sometime what happens now? Like, look, the biggest problem in this particular kind of setting was this, that maintaining the joint probability becomes very difficult. So one method could be that that is a very interesting method that is called the graphical method to represent the dependencies. So what I just wanted 1 minute. So what I just told you, I told you this that finding out the I told you that finding out the joint probability, for example, A1, A2, A3 given something becomes very difficult because you don't know that what is the relationship they have. So you have applied a notion that A1 given Y multiplied by A2 probability of A2 given Y probability of A3 given y. You translated this into this particular way, but this is not a right way to do that. Is there a better way? So this comes, so graphical models comes into the rescue. They gives you a better understanding. What they do, they actually try to give you a kind of a kind of graph that makes the things, the finding out this probability becomes easy by using those kind of things, because you know that when you are living into the world, you cannot assume that everything is independent. Na? This is the basic assumption. There is some dependency. Okay, for example, mm, so everything is, you know that if it is raining, if you go outside, you would not be able to find out the taxi easily. For example, you say that let's assume that you are living in a place where finding out taxi is easy. But if I put another condition, it becomes difficult. Why? Because that condition has an effect on this particular thing. So this is how the things are actually they are actually related in real world. But into the mathematics, we don't know. If you don't represent this knowledge into the mathematics, then you don't know. So it may be possible that everything are actually related to each other, and you think that everything is related to everything. That's not a good idea. Okay. So to tell me, to give you the more better idea for the graphical model, I have an example, and let me give you that particular example. Then it will be easy for you to understand. So this example actually need a story. The story is this: that one morning Tracy leaves her house. So there was some lady Tracy, and there was some person Jack. Their house was side by side. Okay. So when the Tracy was going out, she saw that his grass is wet. So his grass was actually wet. Okay. So she she was actually thinking that whether it was due to overnight rain, or she forget to turn off the sprinkler last night. It may be possible that she has switched on the sprinkler and she forget to turn off the sprinkler. So sprinkler was on or off. There are two conditions: sprinkler was or off, on or off for the overnight. If in the overnight it was sprinkler was on, then definitely it is going to be wet. Okay, and if it has been rain, then also it may be possible. So she was a confusion that what was the reason. So suddenly he noticed that grass of the neighbor Jack is also wet. So this was the confusion. But she also noticed that the grass of Jack is also wet. So do you think that let's assume that when this was the confusion, if I just wanted to tell that what is the probability that his sprinkler was on. So let's assume that he was thinking 0.5. But when he saw this particular thing, then this probability should change or not. 50-50 she was, no? It looks like that 50-50 she whether she has forget to turn off the sprinkler, or it was a rain. Let's assume that she was on 50-50. But when she saw that Jack's things is also wet, looks like that probability of rain is actually getting more. Okay. So in this particular kind of setting, so let me define some variable. So let me define some variable. R is equal to 1 means rain. It rained last night. Simply I say R means rain last night. Not R means not rain. Sprinkler was on last night. Jack's grass is wet. Tresia's grass is wet. So these are the four conditions. So how can you model this thing? How can you model this thing? So all these variables you can assign a value. Okay, how many variables you have? You have variable as R, S, J, and T. R means rain last night. S means sprinkler was on. J means J's grass is wet. T means Teresa's grass is wet. I can put many things: 0, 0, 0, 0. Not rained, and sprinkler was also not on. J grass is not also not wet. Teresa's grass is not wet. J's grass is wet. and everything is 0. I can write like this. You can understand this 1 1 0 1. What does it mean? 1 1 1 0. What does it mean? Can you tell? For example, this there was no rain, sprinkler was on. Jack's grass is also Jack grass is also wet, and Teresa's grass is also wet. 1 1 0 0 means what? Rain was there, sprinkler was on. Grass of Teresa and Jack both were not wet. So it is absurd thing, but because of setting you can do all these things. How many settings are possible? 2 to the power 4, because you can apply two values to all any of these values. So 2 to the 16 spaces are actually possible. Okay, so this is an important thing to know. This slide is important, and actually this is the slide that actually I wanted to tell to you. So 1 minute, what happens? Black. Yeah. Okay. So I wanted to find out this particular quantity now. What is the joint relationship between joint probability of T, J, R, and S? What is the joint relationship between them? So generally, what happens that you can. This is the standard method to write that probability of T given J R S multiplied by probability of J. This is called the marginalization RS, then probability of R given S, and then probability of S. You want to find out these particular quantities. But here just see that probability of JRS. What is the probability of JRS? Given J, R, and S, you want to find out that Teresa's grass is wet with respect to J. Jack grass is wet, rain was there, and Teresa's grass is wet. Okay. T means Teresa's sprinkler was on. You may assume that Teresa's grass is wet depends on directly on whether it had not had been raining and whether not her sprinkler was on. So his grass is wet only depends upon what? Whether a sprinkler was on and rain was there or not. It does not take any, it should not depend upon the Jack's thing what is going to happen, because it's a different place. So grass can be wet by only two factors. What are those factors? Whether sprinkler was on or rain was there. So this particular quantity where three variables were there, because of our knowledge we can convert it to the two variables. Similarly, Jack's grass is wet is influenced by only
Sir,
one thing. Yes.
excuse me, sir. Like there may be chance that both can happen, no? There, that sprinkler also she might have put on, and at that time, by chance, like there was
Rain,
overnight rain.
correct. So that's why I'm not removing this variable. Na? R and S both are there. Sprinkler and rain both are going to affect this whether his grass is wet or not.
Okay.
I am removing only Jack because Jack can also do some kind of watering. So Jack is not directly dependent, and this is coming from our understanding from the word. Similarly,
Okay.
here
Okay.
assume Jack's grass is influenced only directly by whether it was raining or not, because sprinkler in Teresa's house does not make the wet into the Jack's room. So J is dependent upon R only. So similarly, R given S. Okay, we assume that rain is not influenced by the sprinkler. If you on your sprinkler or not, then rain is not going to influence. So this R given S is actually probability of R. So if you change this, the formula becomes this. Okay, so formula gets simplified, and this simplified formula has the issue that see two parameter, one parameter, one parameter, one parameter only. So it becomes 4 into 2 into 1 plus 1 and when only 8 different conditions values we needed. Earlier we needed 16 values. So by this finding out the joint probability we can simplify, and this is the exact mathematical representation, and that's why whatever condition, whatever probability we are going to find out is going to be exact probability. There's no problem on that. So this thing can also be represented using this particular diagram, and this is the crux of all this teaching. And what is this? It probability of R and probability of S. Just using this thing, how can I create this? If you understand this particular part, you have to solve a big issue. I am writing this thing. Okay. Here PR and PS are there. Okay. So whenever in the formula, once again, 1 minute. Oh my God. What is this by Control A delete? Now I put Control V. Okay. So what I wanted to tell that yes. So what I wanted to tell is this, that here in this particular formula, there is R, there is S, they are independent. But J depends upon R. So whenever you write J, you still write this particular thing. Yes or no? Then there is third parameter T. T depends R and S. So you write T and you say that R and S. Is it clear? It depends R and S. So this diagram, by this diagram, you can immediately write for the independent thing, you write that probability of S, probability of R, and probability of J given R into probability of T given R and S. So this is using this, you can immediately write like this. So if I ask you that what is the joint probability of sorry, there is no P, why I'm writing this. What is the joint probability for these variables? Again, R, S, J, T. If I want to find out, you write this statement. Instead of writing this statement, you are going to write the below one. And finding out this is easy because less dependents are there. So you can easily represent this particular formula. So by this, you can find out the probabilities. Okay. So this is called the belief network. This diagram is called the belief network, and how you use it, you can understand. For example, here, if I using this belief network, if I ask you that what is the probability joint probability formula, you can say that joint probability of x1, x2, x3, x4 is equal to probability of x1 given what? x2, x3, x4. Probability of x2 given what? x3 and x4. Probability of x3 given what? x4. Okay, only one is dependent, and the probability of x4. This is called the belief network. Similarly, what is this? Probability of A, probability of B, and probability of C given AB. So if this kind of things is given to you, you can create this thing. So, so if this, let's assume that all the probabilities which actually was needed was given to you, then you can compute all these probabilities, and if you can compute the probability, it comes out to be 0.3382, and the computation is given it on this particular page. Next thing that I wanted to talk about is the classification, and you know that classification is a very fundamental task of machine learning, where there are few predefined labels, and we want to attach that particular label to one of the item. And very important thing is that this list should not be very large. I mean, number of labels is not very large. It into control where. For example, here there are, in this example, various kind of grains are there. So your task is to assign a label that, for example, gram and whatever, wheat or whatever, to that. So ultimately you want to tell that this item is of this particular kind, something like that. So you want to attach a label. Okay. So how can you do that? Definitely you have to find out some attribute from this item. For every item, you, for example, what is a color, texture, weight, density, and based on this feature, you are actually going to find out that apply that particular thing. So one first thing that I wanted to first method of classification that I wanted to discuss is called the KNN, K nearest neighbor. So what happens that this algorithm actually says that, for example, let's assume that into two-dimensional space, these are the red point and these are the some green point. Let's assume that red and green points are given to you. And we want to find out that what is the classification of a new point. Let's assume that this is the new point for which I wanted to find out what the classification. So k nearest neighbor says that there is a value k, that how many nearest neighbor I wanted to consider. So let's assume that the k is equal to 3. So I want to find out that who are the 3 nearest items to that. So let's assume, looks like that these 3 items are near to me. So I draw a circle and try to find out that who are the 3 items which are near to me. What is their class? Their class is red. So that's why this item is also going to be red. Okay. So let's assume that in the same way you can find out the classification for any other item. So this it is a two-step algorithm, and where you have to first find out the k nearest item, and then you apply the majority weighting on that. And finding out the k nearest point is actually not that easy. It is most difficult part. Okay. So let's assume that this is the point. Then you can find out 3 point near. Here is a point. Then you can find out the 3 points like this. Then the classification is again red. If the point is here, you find out the 3 points like this. Then three other point. Okay. So it is a green point. You can go ahead like that. Next method for the classification is decision tree, and we are going to talk about that. Decision tree is something this kind of a structure where for given item, so these are the attribute that you have to find out, and with respect to the attribute value, you forward into a particular direction, and then you find out that what the classification for that particular item. So let's assume that there is some item where outlook is rain, wind is strong, then the classification is no. That's it. So so how can you create a decision tree? Okay, how can you create a decision tree? So to understand this thing, let's first understand a small concept that is called entropy. Entropy tells that what is the purity of a data. So if let's assume that two classes are there, and I say that class is positive and negative. So if the class is positive, means all the items are positive only. So there is no negative item. So there is no confusion. So the entropy is 0. So if all the items are negative also, means the probability of positive is 0, all the items are negative only, then also it is pure item. So there is no entropy is 0. Entropy is maximum when the point is 0.5. So the formula, there is a formula that tells that and this is called the Shannon formula. He was a PhD student at the MIT when he has actually discovered this particular formula. So it is one of the most fundamental influential formula for the computer science. Okay. So pi log pi, this is what they say negative of pi log pi. Why negative? Because pi is less than 1, probability is less than 1, so negative values you get. That's why you put a negative things over there. For all the classes, you find out the summation on that. So if you understand that this is the formula of entropy, so this is the data. Can you tell me that what is the entropy of this data? This is the data. Can you tell me what is the entropy of the data? Once again, I have to find out how many classes. So two classes are there. So I divide the data into two parts. So by this you see that 1, 2, 3, 4, 5 are negative items and 9 positive items. So you want to find out the entropy of this particular setting where 9 positive and 5 negative items are there. Put this particular formula. How you can put into this particular formula? Here you can tell what? Here you can tell that pi log pi. So you have to put pi log of pi minus of, and summation is on the classes. So there are two classes. So the same value for pi log pi you have to find out for the one for the positive class, and for example yes, and another for no. So what is the probability of S? Can you tell me that what is the probability of S? 9 things are there. So 9 divided by 9 plus 5. Total number of items are 9.5. What is this P? This it is 5 divided by 9 plus 5. So put this particular formula. Similarly, this quantity would also come over here and you find out what is the log. Log is generally base 2. So you do this, and when you apply this formula and you are going to 0.94. So problem entropy of this particular thing is this. Now I am going to define another thing that is called the information gain of a particular attribute. How many attributes are there? 1, 2, 3, 4. Outlook, temperature, humidity, and wind. These are the attributes. So with respect to every attribute, I have to define that what is the information gain. Formula for information gain is this, that find out the entropy and then the summation for all the values which are here, SV upon S, and then multiply by the entropy. So if this is the data that I have, so with respect to any particular attribute, for example, as sunny, you can create a subset of the thing where, for example, outlook, with respect to outlook, you can find out sunny. With the sunny, how many data items are there? D1, D2, D8, D9, and D11. So you can write like this, and I have just make them red and black based on the whether they are yes or no. So with respect to every attribute, every attribute value you can create this particular data set, that where they have this particular value, and when you have this thing, then you can find out that what is the entropy of this particular data set. So entropy for this small data set you can find out, then find out that how many items are there with respect to the complete items, and then you just subtract from the complete database. So if you want to find out the information gain with respect to a particular attribute outlook, then it is going to find out the entropy of the complete database that we have few minutes back computed. What was this? 0.94 subtracted by what? All the values that this attribute, for example, outlook can take. It can take three values. What? Sunny, overcast, and rainy. So sunny, overcast, and rainy, for every for them you are going to create this thing and find out that what is their entropy. SV upon S you can find out, because S is the 14 and SV means how many items are there. For example, as Sunny has 5 items. So you write the extend the formula into this particular way. So here is an example where this is the formula Sunny, high, and let's assume with respect to the humidity you want to find out that what is the information gain of the humidity. So humidity can two value, high and normal. With respect to this is a database, you divide the things and you put into the formula, you get this particular value. For example, with respect to the wind, you again put the formula, you get this value. So how many attributes were there? 4 attributes were there. So similarly, for all the attributes, you can find out the value. Highest value is for the outlook. That's why with this particular database in the tree, you put outlook at the top. After that, since outlook you have taken, so you divide that what is the value of outlook, sunny, overcast, rain. So far with respect to them, you divide the database again into 3 parts, and with respect to this database you again repeat the same process, and by this you would be able to expand. For example, here if you want to find out what attribute I should put over here, so what are the attribute choices? Okay, what are the attribute choices? So humidity, temperature, and wind, these are the three. Outlook already has been taken. So if you compute the value based on the formula that we have done earlier, it comes out to 0.975719. So you definitely are going to put humidity over here because it has a higher value. Similarly, if you apply over here, you find out wind. By this, you create this table. Okay. So this was a table that was given to me. I wanted to find out the classification for rainy, humidity, high wind. So one again. Look, I'm asking that rainy, high, humidity is equal to high, wind is equal to weak, but I'm not telling the temperature value. So even then, using this that we have few minutes back come up with a tree, we can find out the classification. How? Initially outlook is equal to rainy, so you come into this particular way. Then wind is needed, wind was weak, so you come here, you say that the classification is yes. You know that I have not told you the value of temperature, and 3 values I told, and here humidity was not needed to find out the classification. This is the importance of the decision tree, that maybe all the things are not required. So the decision tree algorithm has a specialized name that is called the ID3 algorithm. Why it is ID3? Because it has been iterative. Diatomizer is the name. Actually, diatomizer is again the same thing that you divide into the different parts. So this comes from the medical domain, because people who actually initially invented this algorithm, they were working into the medical domain. Same algorithm that we have talked about a few minutes back. There are various issues that if you grow the things completely, there is a chance of overfitting, and to reduce this chance, it may be in better way that if you use some kind of other satellite data to measure that what is the accuracy on the verification data when this and based on that you can stop before the actually reaching to the complete depth of that particular circuit. The more important application of this kind of method comes into the random forest, and it is very interesting to tell you that what is a random forest. Actually, what happens now, let's assume that you have a database. Okay, let's assume that you have a database, and then then let me tell you that let's assume that you have a database. So database has various attribute. So if you drop this attribute, what would happen? You get another database d dash. If you drop this attribute, you get another database d double dash. If you drop both of them, you get d triple dash. If you drop this particular row, you get another database d4. You drop 2, drop 4, drop 5. So from one database, you are going to actually create multiple databases. For these update, for all these databases, you are going to create the decision tree. And when a new item is going to given to you, so what you do, you go to all the trees and ask them that what is the classification. So if and see that what is the classification, what is the majority of the trees are going to tell you. So if you apply a majority voting on this kind of setting, it actually it has been found that here you can see now few rows are actually going to be discarded, here few columns are discarded, and then new trees are there. And when a new item is going to come, you find out, you go to consult to all the trees and then apply voting, then whatever is the maximum you are going to take that. This is the very interesting way to do that. So this was the classification that I wanted to talk to you. Next thing that I wanted to talk to you is the regression. And in the regression, what happens that if this is the table, for example, let's assume that this is the table and this is the output value for this particular 11, 31, 22, let's assume 12 is the value. What is this? These values? Don't focus on them. Anything can be possible. So let's assume that these are the few characteristics, and based on this characteristic, you are going to tell me a value. So if this is the table given to you, if I give you a new value 8, 22, 35 and ask that what value should be here. So this is what the regression problem. In this kind of problems, what you do, that you generally model that looks like that given the value of x1, x2, there are some weight which are actually multiplied, and by this we are going to get some kind of output, and this is what the output I have. So this is here in this particular formulation. So this weight are actually the important thing. If I change the weight, then the formula is going to change, and this by this I am going to get something. So let's assume that the same table. Let's assume that I set up some weight, and by this I get this particular value. Okay, by guess this particular value. So if I get this particular value, so using that formula I can apply here also and find out that what is the value for coming to this. Then I can tell that this way here at this place of my question was what should be the value. So the value is 6. But how good this particular value is, if I want to find out how good this particular value is, I have to see that this value, earlier value should be very near, then only I would apply this thing. Otherwise, what is this? Anything, any value you can put it here, anything would come here. Does it a good thing? Answer is no. So first you have to define the goodness, so that if your goodness is high, then this value should not, 8 should be 10, 9 should be 12, or very near to 12, 10, or something like that. So the one way to define is this, that is square difference between these two values, that what is the value of this divided by this value, and then the square value of this thing is actually, you're going to find out the summation of these quantities, and you say that take the average of all the number of items and say that this is 6.33. So you understand this value? Difference is square, distance is square difference, summation of the square difference divided by number of items which are here. 2 you are also dividing, that is not important. So it gives you 6.33. So this value, if this value is 6.33 and I come up with any other parameter which have this value 0. For example, who says this value 1. So which value you are going to prefer? The parameter which gives the value near to 0. Okay, because this is a problem. So there is a method called the gradient descent. It tells that if you go into this particular way, you would be able to find out the right parameter. Means when the error is actually, so what happens now, initially it may be possible that your error is high. Initially it may be possible that your error is, for example, in this particular case, what is the error? Error is 6. Okay, in this particular case error is 6. After that you change the value of w's such a way that it becomes 4, change this in such a way it becomes 3, change this such a way it becomes 1. So how to change this thing? So one method is called the gradient descent. It tells that whatever is the value of j you have, if you find out what is the derivative of this particular value, derivative tells that how it increases when you increase the value of that parameter. So you don't want to increase the j, so you subtract this value with respect by multiplying alpha, so that this value actually reduces. So if you modify the weight by use this particular formula, weight minus alpha time derivative of the value with respect to jw, so your weight are going to adjusted in such a way so that this particular error is going to be reduced. This method is called the gradient descent and very applicable method into the computer science. And in this kind of setting, what happens then, generally what happens that when all the complete data you are going to take, then at the same time you are going to modify the value. However, there is another method that tells that one minute, let me tell what I'm telling. So I think all these things you already know, but just the sake for completeness I'm going to iterate. If you have any question, please ask. So what I was telling, that if you have a database, using this particular database you want to modify the parameter. So for all the items you compute that how much you have to change, and after that you change this particular parameter. Another idea could be that in this database you can divide into parts, and for this particular part you compute that how much change I have to do, and you change this thing, then you go to the next part. Extreme way could be that if for every item you are going to compute that what should be the change, and then you keep changing the weight of w. So they all these things are possible, and they have a specialized name, such as when I say that when I'm going to take the item into 30-40 items, something like that, then I can say that it is a batch gradient descent. And another method is a stochastic gradient descent, where for every item I'm going to change this. So this last landscape that few minutes that I had talked about, this last is not that smooth surface where you find out that a nicely place where there is a minimum and you can reach to that particular point. It is something like this. This image has been taken from a paper. So here, if you want to go to reach to this absolute minimum, you must start somewhere here. If you start here, you would be stuck into this particular place only. Okay. So this is the gradient descent example where I have set a learning rate, say 0.01. This was the data. Let's assume that this was same data that I'm talking about. So if you keep training, what happened? J was 396. After that, J increased, J is getting increased. So you can see that whatever method I told you, it is not working because J is actually increasing. Initially the weight was this, then it becomes this by the method that I just talked about. But if I change the value of alpha to 0.01, it becomes something like this. Again, you can see that it is increasing. So it is also not working. When I change it 0.001, learning rate I have changed to 0.001, suddenly it start working. 396 from it reduces to 27, and you can see that what are the weight with respect to that. So learning rate plays a very important role into the learning. Okay. To make it fast, and there is method, it is called the feature scaling. So you can apply min max scaling with respect to every attribute, and when you do that, it becomes very fast. For example, here after 18 iteration, you started by 0.95. When you do this, you started with a 95, and after 18 iteration, you reach to 24. The previous one, you see that after 300 iteration, you are reaching to the 24. So it becomes very fast, and after 30 iteration you reach to 23rd, 3000 iteration you reach to 20, so it becomes better classification. Okay, so this is how you find out that if I want to find out a value over here. Earlier I was talking about what? Classification. After that, what I talked that after classification we had talked about that if you want to find out a value. Okay. And now again I'm going to ask you that it looks like that it is a good method. So can I also apply this method for the classification? So again, then changing my problem. Let me change my problem once again. I say that instead of value in the regression I was having the values. Now I'm telling that again I'm going to find out that what is the classes over here. So I wanted to find out what value should come over here. Okay. So let me plan the same thing once again, that on this particular thing I apply some kind of classifier. It is going to give me 0 or 1 value. So I can apply the sigmoid function over there. Sigmoid has the value from 0 and 1. If this value is very less, I say that it is class 0, otherwise class 1. In between, we can apply a threshold. If greater than 0.5, I say that one class 1, otherwise class 0. So I have changed the formulation. Earlier it was only W's multiplication. Now I am telling that there is sigmoid also. If I put like this, then there is a there is a possibility that I can come up with a decision boundary that can actually give me that inside the values are of positive, other side negative, then I can get the decision boundary. But the point is that how I was training over the system, I was training using how I was doing the gradient descent using this kind of mechanism uh, called the error function, and the error function was given by this particular formula. The issue is that when you apply sigmoid on this particular quantity, this function becomes non-convex. And why it is not convex, if you want to find out, please I request you to go and complete lecture from my machine learning course. However, it is not needed into this particular course. You just understand that it is not convex. So it is not convex, then we cannot apply the method because it requires the derivative. So what should we do? So the method is that you apply a cast function. Cast function says that log of this quantity when y is equal to 1 and log of 1 minus y your classification otherwise. So you can simplify this thing, and cast function because it's 1 and here it is 0. So you can apply and multiply. You can write into this 1 minus 0 kind of thing. So you can make a single line statement like this. Once again, what I was telling that cast, the function which was cast function was there. I change from this particular setting to this particular setting. If I change it, then it becomes again convex, and then I can start training. Similar way, logistic regression we can apply and we can find out, we can train this particular system. Same formula, however, the issue is this only changes this, that when I wanted to find out value of y, it is not the multiplication of w's but sigmoid of that particular quantity. Again, I can say that with this particular learning rate, I can show you that how the j is actually reducing, and by this I am going to get the better classification. So how to find out the value of j, how to find out the value of w are again the simple thing that you can do, and now you can do the learning. Okay, and here this is an interesting thing that shows that training example where x values are specified, y values are specified. Initially, after one iteration everything was 1, after 100 iteration everything was 0, after 300 iteration it was something like this, and after 500 iteration it was something like this, and it means that they are actually the same. Please note, you cannot get anything from here. If I give anything over here and ask you that can you reduce the error, now this time you cannot do, because you can only do if the things are linearly separable. Earlier it was not the condition. If the things are not linearly separable, you would not be able to do this. So this actually is an important thing that to know, that if actually this particular data that is given to you, if it is linearly separable, then only after sufficient number of iteration you would be able to reach to the right parameter which actually solves your particular problem. Next thing that I wanted to do is clustering, and you know that clustering is very simple thing. For example, if these items are given to you, you can say that 2 clusters are there, or you can say that 4 clusters are there, or 5 clusters, becomes depending upon your requirement. Okay, so so it is unsupervised in nature, and very important thing is this, that the clustering approaches could be, sometime you wanted to find out well separated cluster, sometime you wanted to find out center based clustering, contingency based clustering, density based clustering, etc. So so you can see that these 2 clusters are separate. Here 2 clusters are touching, but they are not same. Okay, here you can see that it's few items is there, then is a connection, then this comes into the same one, and this into another class, this comes into another class. Here clustering is done based on density, where here no item is there, the one cluster less dense, the second cluster, this is the third cluster where more dense things are there. Here conceptual clustering, where you can say that a square is there, triangle is there. Here you can say 2 rings are there. So here you can see that this item belongs to both the rings. So all these kind of clustering is possible. I would take this clustering in more detail into the next class. However, I would like to stop at this particular moment. If you have any questions, please let me know. The slides are with you. You can just go through with them. I would stop at this particular moment and